Hi friends, Miss Chang here. I'm sorry that I'm missing you today, but I know I didn't want you to miss me too much, so I decided to make a little video for you. So before we get started, you're going to need to get the Assessing Normality worksheet, that handout from the sub. So grab that real fast, and then here's a little warm-up. You can pause the video at any time and then restart, go back, listen again, because I know you want to hear my voice again. So anyway, take a minute, draw a little picture, try this problem. It's a little different than something we've done before. All right, now that you've worked through, here are the answers. Okay, so check your answers. I'm not going to go through the whole thing, but basically, in order to answer this question, you had to draw a little picture. And you know that Tyler spends less than 1 minute brushing his teeth about 40% of the time. So here's 1 minute. Less than that, he spends about 40% of the time, right? And then he spends more than 2 minutes brushing his teeth about 2% of the time. So here's 2 minutes. He only does that about 2%, okay? So you're going to have to look up z-scores that match up with those percentages, and you're actually going to have to solve a system of equations, okay? All right, so here's our agenda. This is what we're going to go through today. We're going to talk more about normal probability plots. I have homework answers for you. Your homework is going to be a couple problems from the book. I'm also going to give you some review problems that you can be working on later on in the notes in this video, and just some updated dates, okay, of what's going on. So down here. All right, so guys, here's the homework answers that were due today. So I'm going to go through them pretty fast. Just pause the video and take a look whenever you need to. Here's the rest of 2.31. And then here's 2.33 and 2.35. Okay, so normal probability plots. We already did a lot of this. We talked about how they were constructed, okay? And we answered this question too. You know, if the data really does follow a normal distribution, the plot should look linear because the distances between your original data are going to match up with the percentages from that normal distribution, that z-chart, okay? So we're going to take a look at 3 normal probability plots, and these are in your books. I took screenshots for up here too, but on page 150 to 152. So here's a couple examples. This, I believe, is on page 150, okay? Here's a normal probability plot of the breaking strengths of wires bonded to a semiconductor wafer. So look, here is this example refers back to some data on page 54, okay? So here's the data on page 54, and they made a nice little histogram for you. You can see that it is approximately symmetric, and you might have 2 outliers, right? Or really 3 outliers, but we think that it's symmetric, so is it normal? Well, we can go back and we can make this normal probability plot using your calculator. I'll show you how to do that in just a second, okay? And remember, we talked about what the normal probability plot looks like. Here down on the x-axis we have our z-scores. Some are negative, some are positive. And then here we have the original data, right? This is our breaking strength, okay? So, like, basically this piece of data, the breaking strength looks like it's about 0. The corresponding z-score is a -2, okay? Because this follows this, you know, approximately linear path, this gives us evidence that the distribution of the original data, in other words, the distribution of breaking strengths, is approximately normal. Here's another example. This is the next page in your book. What is it? Page 151, I believe, okay? So here's some survival times of 72 guinea pigs after they were injected with this bacteria in a medical experiment, all right? I know, so sad. So take a minute, if you'd like to, pause it, make a little graph using your calculator. You're going to see that there's going to be a strong right skew to this distribution, okay? So when I make my probability plot that matches up with this data, again, z-scores on the x-axis, the survival times on the y-axis, you can see it has this, clearly curved shape. It's no longer linear. So this gives us evidence that this distribution is not normally distributed, okay? So the survival times in days of the guinea pigs is not normally distributed. Which, again, you can tell by, obviously in this case, by the original data because it does have such a strong skew. But here's another example, okay? Again, this is page 152 from your book, all right? So researchers collected data on the acidity levels in 105 samples of rainwater, all right? Here's the normal probability plot. Here's the z-score on the x-axis. Here's the pH value of the rainwater, okay? Again, this has that like pretty linear shape. It's not perfect, but it is pretty linear. So we think that the distribution of the acidity level of this rainwater is approximately symmetric. All right. So going back, this is a direct quote from the book, okay? When you examine a normal probability plot, don't look for shapes that show clear departures from normality. Don't overreact to minor wiggles in the plot. So again, it's not going to be perfect, okay? But it should be approximately straight, that line. Your normal probability plot should be approximately straight. And if it is, then we have evidence that the distribution, the data follows a normal distribution. All right, so now that we know what they look like, what the normal probability plot looks like, let's talk about how do we use this? So basically, you're given a set of data, and we ask you to determine, do you think that this distribution follows a normal distribution, yes or no, okay? First thing you should always do, enter the data into your calculator and draw a histogram, a stem and leaf, a box plot, a dot plot, all right? If your histogram or whatever it might be is not symmetric, if it's clearly not symmetric, is there any way that it could be normal? No, right? So that's the first thing that you should look for, all right? After you do that, we know the distribution is symmetric. It should look something like this, okay? But we don't know that it's normal unless we check. So do you remember we checked the heights of our classmates? We made like a little table and we said, oh, look, these percentages are pretty close to 68, 95, 99.7, right? So that's one way that you could say, okay, the shape of the distribution is approximately symmetric. It matches up to the 68, 95, 99.7 rule. Therefore, we think that the distribution is approximately normal. Your other option is to make a normal probability plot. I'm going to show you how to do that on the calculator in just a second. And again, if the normal probability plot follows close to a straight line, we have evidence that we think that this data was approximately normally distributed, all right? Again, remember, it's not going to be perfect, okay? So now I want you to take out that worksheet that you got from the sub, this assessing normality worksheet, and we're going to go through it together. So pause the video, take a second, get this data into your calculator. All right, guys, so you have all that data into your calculator. So again, first thing you should do is you need to make a graph, all right? So it could be a histogram, could be a box and whisker. You can go crazy and make a dot plot, whatever your little heart desires. Oh, this is not going to cooperate. Hold on. Okay, so I have my data in L1, okay, and I have this set up to make a box and whisker, so I'm just going to go with it. Zoom 9. Okay, so that looks like it's approximately symmetric. Take a minute, make your own graph, use the calculator, and then jot it down on your paper. You can pause the video and start again when you're ready. Okay, so we made our graph, right? Now we're gonna go and we're gonna just jot down some important information, okay? Mean, standard deviation, time number summary, all that stuff. So take a minute, get all that down. All right, now we're going to test for outliers, okay? So I have to do my 1.5 IQR test, right? So I'm going to do 1.5 times Q3 minus Q1, right? So, this one will be easy, right? And then I'm going to add that, so add 15 to Q3, so 84 plus 15, and subtract it from Q1, right? So my range of good data goes from, that'll be what, 59 to 99, right? Okay, so my range of good data goes from 59 to 99. So if I look at my test scores, did I have anyone that got below a 59? Now, I have someone that earned a 59, right? But I don't think I had anyone that got below a 59. And I did not get anyone that got above above a 99. So, no outliers, right? Okay, so let's take a minute and describe the distribution in context, right? So, where am I? Oh, I want my calculator, sorry. So, the shape of my distribution, we said it's approximately symmetrical, right? So, I'm just going to kind of write bullets for the sake of time. So, the shape is approximately symmetric. The center of my distribution, because it's approximately symmetric, we should refer to the mean, right? So the center, the mean is 78.158. Now, I don't know if these are percentages or whatever, but this, so I would say something like, you know, if you're answering this on a test or a quiz, I would say something like, the mean test score was 78.158. Again, this is now putting this in context, right? So the spread is going to be the standard deviation. So the standard deviation of the test scores was 9.197. Because again, I'm not sure if these are percentages. It looks like they might be, but I don't know for sure. And I would say that there are no outliers. Okay? All right, so now I've described the distribution. Now, we're going to take a minute and go back to the calculator and look and see how we draw a normal probability plot, or how we create a normal probability plot. So if I go back to my calculator, and if I go to second stat plot, I'm in plot 1. This option all the way over here on this far right side, that's your normal probability plot, okay? I'm going to hit enter. So my data is in L1. That's my original data. My data axis. That means where do you want the raw data? Do you want it to go across the x-axis, and that means that the z-score would go up the y? Or do you want it to go on the y-axis, and therefore your z-score would go on the x? So you can choose, and remember we talked about in class, like you should be familiar, you could see it either way, right? So far the normal probability plots we've looked at, the data axis was like the y, and the z-scores were on the x. So let's keep it on the x just so you can, you know, see something different. Okay, I'm going to zoom 9 it. And there you go. There's my normal probability plot, okay? I'm going to just check my window real fast because I want you to see something. These are z-scores, right? My z-scores, the y-axis is now my z-score, okay? So my window in the y direction, right here, you can see, goes from negative 2.59 to 2.59. It's centered around 0. I can see this, you know, x-axis here, or in other words, y is equal to 0, is right in the middle. That's the middle z-score, right? That's the mean. That's the center of my distribution. Okay, and then my x values, here's my x-min and my x-max. For x-max, those were my test scores, right? So from 55.4 to 98.6. There you go. So I'm going to draw a rough sketch. And when I say a rough sketch, I mean a rough sketch. Like, watch. I'm going to try and put these side by side. Is this going to work? Probably not. So, look. Here's my rough sketch. There's my x-axis. I have a bunch of data there. Kind of goes like this, and then down at the bottom, okay? That is my rough sketch. It doesn't have to be any better than that. So that's my normal probability plot. Interpret this. So because this the normal probability plot follows a close to straight line pattern, we have evidence to say that the distribution of test scores is approximately normal. Okay, does that make sense? So the distribution of test scores is approximately normal. Okay, so number 5, find the percent of data within 1 standard deviation, 2, and 3 standard deviations of the mean. So basically, we're checking the 68, 95, 99.7 rule. Now listen, if I were just to ask you to assess the normality, does this distribution follow normal distribution? You don't have to do both number 4 and number 5. Do one or the other and say, therefore, it's approximately normal. But I'm just going to remind you how both works, okay? So here's a quick reminder. Here's my mean and standard deviation. I rounded a little bit to make it easier, okay? So my ranges are going to be, within 1 standard deviation, my data ranges are going to go like this, right? 78.2 minus 9.2, so 69. Then within 2, so minus 9.2 again, so 59.8, and then 87.4 plus 9.2 is going to be 96.6. And then within 3 standard deviations, so 50.6 all the way up to plus 9.2, so 105. Okay, so those are my ranges of data. Now, I have to basically go back to my calculator. Remember, we can sort L1, put these in order, okay? I'm going to go back to stat list. Now, how many of these are out of this range? So between the range of, I'll give you a minute. I can't fit this all on the screen, sorry. So take a minute, pause the video, and fill in the percent of data. Okay, So there's my percent of data within each range. So it looks like it matches up very nicely with the 68, 95, 99.7 rule. So again, this gives us more evidence that we think that the distribution is approximately normal. All right? Okay, guys. So now that we kind of finished up talking about normal probability plots, you saw how to make it on your calculator. There's directions how to do that in the textbook as well. Here's some review problems to kind of get you ready for the quiz on chapter 2.2 and also the test review, all right? So copy these down, try these book problems, and I'm going to scroll. I have answers here for all of these that I'll kind of scroll through so you can kind of pause one at a time. I'll also post all of these answers up on Schoology this weekend, okay? So here's the chapter 2.2 review problems. And then these are the chapter review problems. All right, guys, thank you so much for listening. If you have any questions, I'll give you time to ask before your quiz next week, and I'll update all the dates and everything on Schoology. Have a good day. See ya. Thanks.